Today, we are diving into an absolutely monumental engineering feat. We're talking about the construction of a new generation of ocean giants, ones that are specifically designed to make global trade a whole lot cleaner. So, let's get right into it.
So, to really get why this project is such a big deal, you have to start with this number, 90%. A truly staggering 90% of all international trade travels by sea. I mean, think about it. The phone in your hand, the clothes on your back, maybe even the coffee you drank this morning. It's all thanks to the sea. It is the absolute backbone of our global economy.
And that right there leads us to the huge challenge facing the entire shipping industry today. All that movement, all that trade, it comes at an environmental price. So the big question on everyone's mind is, can we innovate our way out of this? Can we find a more sustainable solution? Well, one French shipping company, CMA CGM, decided to take that challenge head on. And their mission was, let's be honest, incredibly ambitious. They didn't just want to design one eco-friendly ship. No, they wanted to build an entire fleet of 9 of them. And get this, they wanted to do it all in a record-breaking 2-year time frame.
Okay, so first things first. Let's try to get a sense of the sheer scale we're talking about here. Because these aren't just big ships, they are true titans of the sea.
I mean, the numbers alone are just mind-boggling, but when you put them into perspective, that's when you really feel it. The ship's length, that's 4 football fields laid end to end. Its weight, the same as 7 Eiffel Towers. And if you took all the containers it can carry and lined them up, that line would stretch for 150 kilometers. This isn't just a ship, it's practically a floating city.
So how on earth do you build something this massive, and 9 of them no less, in just 2 years? It sounds impossible, right? Well, the key was a totally brilliant modular construction method. Instead of building it from the ground up, piece by piece, they built it in massive, prefabricated chunks.
And it all starts with some serious heat. The steel sheets that form the ship's skin are cut with a laser that operates at 18,000 degrees Celsius. Now, to put that in context for you, that is 3 times hotter than the surface of the sun. It just slices through industrial-grade steel like it's nothing.
The process, when you break it down, sounds deceptively simple. It's just 3 steps. First, these super powerful lasers cut over 12,000 steel sheets. Then, those sheets are welded together into huge sections they call blocks. And here's the real genius part. These blocks are pre-fitted with all the pipes and wiring before they're even part of the ship. Then giant cranes just lift them into place and join them together, like the world's biggest, most complicated Lego set.
And these blocks are not all the same size, they vary dramatically. Some are as small as a single room, but the largest ones, they're as big as multi-story buildings, weighing hundreds and hundreds of tons. This whole method is what allows thousands of workers to work on different parts of the ship all at the same time. It's a game changer.
But here's where it gets really, really tricky, the precision. When you're lifting a 790-ton block, that's the weight of 2 train engines, there is absolutely zero room for error. Each of these giant pieces has to align with millimeter accuracy. A tiny mistake, even one, could put months of work in jeopardy.
And once those blocks are perfectly in place, the welding begins. The total length of welding on just one of these ships is 1,250 kilometers. That's like drawing a continuous welded line from Paris all the way to Budapest. And every single inch of that weld has to be flawless to withstand the brutal forces of the open ocean. Now, the steel structure is incredible, no doubt, but the true revolution, the thing that really sets this ship apart, lies in what powers it. This ship isn't running on traditional dirty fuel. No, it's powered by something much cleaner, and that required an engineering marvel all its own. That power source is liquefied natural gas, or LNG. It's a fantastic, much cleaner alternative to heavy fuel oil. But there's a catch, and it's a big one. To keep LNG in a liquid state, you have to store it at a constant, bone-chilling -161 degrees Celsius.
So this brings us to the core engineering puzzle the team had to solve. The ship needs to cross entire oceans without refueling, which means it needs a massive fuel tank. How in the world do you build a tank that large while also keeping it at that extreme cryogenic temperature right in the middle of a ship?
The answer is just brilliant in its simplicity. You build the world's largest thermos. And I'm not just using that as an analogy. That's functionally what they did. This custom-built tank can hold 20 million liters of LNG. It took 9 months just to build the tank itself, using all these layers of high-tech insulation to maintain that absolutely critical temperature.
And here's why they went to all that trouble. This is the payoff.
The switch to LNG results in a massive reduction in pollutants. 99% less sulfur, 91% less particulate matter, and a 20% drop in CO2 emissions. This is a total game changer, because it proves that cleaner shipping is actually possible on a massive scale. It could set a whole new standard for an industry that's under a lot of pressure to decarbonize.
All right, so with the hull and that incredible fuel system in place, it was time to install the other giants, the engine and the propeller. Let's take a look at how these colossal components came together.
The engine alone weighs 2,000 tons. It is the largest natural gas engine ever built. Just its crankshaft, the part that transfers all the power, weighs 220 tons all by itself. And the propeller? A measly 92 tons. These parts are so unbelievably massive, they had to be transported and installed in pieces.
The scale is honestly hard to even wrap your head around. The engine stands 20 meters tall. That's as high as a 6-story building. And the propeller, which was cast in a single solid piece, is 10 meters high, the height of a 3-story house. Putting these things together requires just unbelievable precision.
So after more than a year of non-stop construction, the ship is almost complete. Now comes the final phase, finishing it all off, and then, most importantly, proving it can handle the unforgiving conditions of the sea.
First, it gets a special coat of paint to protect it from all that corrosive salt water, and we're talking about painting an area that is twice the size of Vatican City. Then, it heads out for 15 straight days of intense sea trials. They test everything: engine speeds, emergency brakes, navigation systems, even the anchor. And just as a fun fact, a single link in that anchor chain weighs 300 kilograms.
You know, the timeline for this achievement is just incredible. From the moment the project started, the very first ship was completely assembled in just a year and a half. And by the 2-year mark, against all odds, the shipyard had delivered all 9 of these revolutionary vessels. They literally won the race against time.
In the end, this project is so much more than just a story about building a big ship. It's about thousands of people, immense collaboration, and unbelievable innovation. It really proves what's possible when human ingenuity truly commits to moving mountains of steel and in doing so charting a much cleaner course for the future of global trade.